This is Algebra 2 with Trig. This is the review for quiz 6.1, 6.3. No calculator should be necessary to complete this review. So here we're looking at 9 to the 3/2 power. So it might help you to break this into an index and an exponent, or a power. So this would be the square root, because that's the index. That would be your 2. Typically we don't write the 2. And then our exponent would be the 3. So this is 3 cubed, which is 27. You could also look at it as 9 to the 3/2 power, which is 9 to the half with the 3 on the outside. If you know that a half means the square root, you can still get 27 that way. Either way. So 4 to the negative half power. Remember that the negative takes your value and puts it into the opposite side of your fraction. So currently it would be considered on top of a fraction, so the negative is going to put it on the bottom of a fraction. The half means the square root, so the square root of 4 is 2. It's not plus or minus, just 1 over 2. Here we have it in a radical format. The index is 6. So this could be 64 to the 1/6, or this is the 6th root of 64. Anyway, we're going to break down 64. How would you break down 64? You might notice that that's 8 times 8. And 8 can be broken down into 2 times 2 times 2 times 2 times 2 times 2. Maybe you weren't aware that 64 is 2 to the 6th power. Well, there's 6 of them in there. So you would circle all 6, and the 6th root means that your answer is just 2. Another way you could look at this would be 64 to the 1/6 power. Well, 64 is 2 to the 6th power. So when you raise a power to the power, you multiply. And that's why you get an answer of 2. Here, you could do what's inside the parentheses first. So you're doing the cubed root of 27. Well, 3 times 3 times 3 makes 27, so the cubed root of 27 is 3. The negative is going to put it into the denominator. And when you square the 3, you get 9. Now, if your negative is already in the denominator, then it's going to move it up to the numerator. There's really no need to put the 1 in the denominator. So here we're going to have 1/3. 1/3 times 2 gives us 2/3. 1/3 is the cubed root. The cubed root of 8 is 2, which gives you an answer of 4. You could have looked at this as 2/3, broken that into the cubed root of 8, wrote it in radical form. Either way would work. Here we're going to solve. So one way that we did it in our notes was to raise the power to the reciprocal. And whatever you do to one side, you also have to do to the other side. So 3 times 1/3 gives you a value of 3 over 3, which is 1. So x minus 4 to the first power. Parentheses really aren't even needed here. Well, the cubed root of 125. Then we would add our number across, and x is just -1. Not plus or minus, just -1. That's the only value that could go in here to get you an answer of -125. What would we do first here? We would need to add the 3 to the other side. Now remember, you cannot distribute this through. You cannot call it x squared plus 4. That is not the same thing. The way we get rid of the square is either with the square root or raising it to the power of its reciprocal. Either way you like to write it. Whatever you do to one side, you have to do to the other side. So 2 times 1/2 is 1. So you have x plus 2 to the first power. No need to write that. And the half stands for the square root. So we have 3. Now, because we essentially did the half to both sides, we have to do plus or minus 3. So we're going to have x plus 2 equals 3, and x plus 2 equals -3. So because our index would have been a 2, been an even number, that's why we had plus or minus. Maybe another way you would see this would be x plus 2 squared minus 3 equals 6. We add our 3 to the other side. We take the square root of both sides, and when you do that, you do plus or minus that side. So the square root of something squared is what's inside. So we get plus or minus 3, and that's where we can say x equals -2 plus or minus 3. And we got our two answers, which was 1 and -5. Either way you like to do that. Number 8. Here we have two bases that are the same. What do we do when the bases are the same and we're multiplying those together? We add exponents. We don't multiply 5 times 5. We just add exponents. So to add these, we need to have common denominators. And we're going to have common denominators of a 4. This is a 4, so we're going to leave it with the 1 above it. To make the 2 become a 4, we had to multiply by 2, so we got to multiply the 3 by 2 also. So now we have 5 to the 7/4. If that was in radical form, we could simplify that down, but in fractional exponents, we could leave that. Let me show you what that would look like as radical form. So how many 4s would go into that? 4 goes into 7 one time, so you have 1 5 that would come out, and you would have 3 of them left over. So you could call that 125, but this will be fine as a fractional exponent. If it was in radical form, then you would definitely need to break it down, but if it's in fractional exponent form, you could leave that. What happens when we raise a power to a power? We multiply exponents. Now, if you're trying to figure out which is the correct form to leave it in, most likely you would leave it in fractional exponent form because you started out with fractional exponents. That would be the better form to leave it in. But I want to be sure that you do understand that half power does mean the square root. Now, because our indexes are different, we cannot multiply the radicans together. So really, one of the useful ways to do this is to break it into fractional exponents or rational exponents. Then we would distribute the 15 through. And that would give us 3 over 5 times 3 over 3. And when the bases are the same, we can add exponents. And you can leave it as 3 to the 8th power. I would expect you to know what 3 to the 3rd power is, or perhaps 3 to the 4th power, but you don't need to memorize or calculate even what 3 to the 8th power. Okay, for number 11, notice that the indexes are the same and the radicans are exactly the same. So really, this is 28 times something minus 12 times that same something. So it's just 16 times that something. 16 times the cubed root of 2. There's really no work to be shown. 28 minus 12, 16. And you bring down your radical. Here, the indexes are the same, but the radicans are not the same. They have to be the same. So if they're not the same, maybe there's a way to turn them into the same. Well, 16. What can 16 be broken into? Eight times 2, and I like to use 8 times 2 rather than 4 by 4. 8 times 2 because I know the cubed root of 8. Nothing can happen to this side. Can't be reduced. Well, the cubed root of 8 is actually 2, so I'm going to bring that 2 out and leave the other 2 sitting inside. So now I notice that the radicans are exactly the same. Simplify this together. 7 times 2, not plus. So that's going to give me 4 cubed root of 2. On the flip side, we're looking here and we're subtracting 2 radicans or two radicals, looking at the radicands, the values inside these cubed roots, they're different. They can't be different. There's nothing we could do with this unless we can make the radicands the same. So 81. 81 can be broken down into 9 times 9. That's just two numbers the same. But 9s can be broken down into 3 and 3 apiece. So this is really 3 to the 4th power, or you might say 27 times 3. However you want to break that apart. And how should we break apart 24? We would most likely want to use numbers that are perfect cubes. So we're going to use 8 times 3. So the cubed root of 27 is 3, and we happen to still have a 3 in the side. The cubed root of 8 is 2, and we still have a 3 inside. So now we have 3 times something minus 2 times something. So that's going to give us 1 times that same something. 3 minus 2 is 1. Here we notice the indexes are the same, which is a requirement to be able to add or subtract, but the radicands are not the same. Can we make them the same? So, what can I do? How can I simplify this radical? Just focus on the radical itself. There's nothing I can do with the 5. The x I can break into 4 of them and 3 of them. Because if I have 4 of any one item, I can pull it out. So this is now going to become 10 times x, the 4th root of 5x cubed, minus x, the 4th root. How are we going to come up with 80? If you don't know and you need to go to the side, you can say 80 and break that apart into maybe 8 times 10 and break that apart into 2 times 2 times 2 and 2 times 5. So there's 4 of a kind, otherwise known as 16 times 5. So I'm going to use 16 times 5 and x cubed. So the 4th root of 16 we saw was 2. So I'm going to bring my 2 out and multiply with what's already out there. The 4th root, I took the 4th root of 16, so I'm left with 5x cubed. And look at that. The indexes are the same. The radicands are the same. And we even have like terms on the outside. So this becomes 10 minus 2 is 8. 8x, the 4th root of 5x cubed. Be sure your index truly looks like an index. Don't mistakenly have it too far over or too big. Okay, let's look at these. Let's think about the domains for these also. The domain for here, all real numbers plus non-negative numbers gives you a domain that would just be non-negative. And the same thing here, the domain here would also be non-negative. You've got to look for where the domains would be the same of those two terms. You can use any number in a cubed root, but you can only use numbers that are not negative in a square root. When we add these two together, the f function, The plus, there's no need for parentheses. So to collect our like terms, the 1/3 and the 1/3, so we have -5 and +3 to give us -2x to the 1/3. We don't do anything with the exponents if we're adding or subtracting. +2x to the half power. That's the best we can do. And again, our domain would be x is greater than or equal to 0. All real numbers for 1/3, but it's limited for the half. So altogether, you can only use the limited amount, which is the non-negatives. So we're going to take our g function, which is 3x to the 1/3 minus 4x to the half, minus, got to use parentheses now because of the minus, -5x to the 1/3 plus 6x to the half. Distribute. And collect our like terms. So you bring the 1/3s together. And the halves together. And again, our domain for this would be non-negative numbers. So x is greater than or equal to 0. Here we're doing composite functions. H of r of x. So every parenthesis is like the word of. H of r of x. So our h function, the r function goes inside of it, x plus 3 divided by 2. So now we take our h function, 2 times something plus 3, and we plug the x plus 3 divided by 2 inside of it. Now there's a couple different ways we can simplify this. We can either distribute the 2 to the top numbers, call it 2x plus 6, and then reduce, or we could just reduce right here. 2 divided by 2 is 1. 1 times x and 1 times 3. Don't need parentheses anymore. Now looking at these, all real numbers would be our linear equation. And this, notice, yes, it's a fraction, but the x is in the numerator, so it is still linear. So since it's made of all real numbers and it produces another linear equation at the end, nothing's limited here, so our domain would still be all real numbers. Last question. R of h of x. So we're going to take the r, plug the h inside of it, 2x plus 3. The r function is something plus 3 divided by 2. Well, that something is the 2x plus 3. Here we can clean that up to be 2x plus 6. There's nothing else we can do with the 2x plus 3, and the 3 is being added to that. You don't distribute it in, you only do it with the like terms. It's not multiplication. And we have the division by 2 on the bottom. Now, when we simplify, whenever you have a plus or minus, one way you could think about it is to break it into both pieces. And that can be reduced into x plus 3. Again, the domain here would be all real numbers. Because you don't have an x in the denominator, you don't have anything inside a radical. Good luck.